Hi! In this video you will learn to implement the greedy algorithm from the previous video and to analyze its running time. Here we have the pseudocode for this algorithm, and the procedure is called min_refills. And the main input to this procedure is array x. From the problem statement we know that the positions of the gas stations are given by numbers from x1 to xn, and those are measured in kilometers in terms of distance from A to the corresponding gas station along the path from A to B. For convenience, we actually add to array x positions of point A, which is x0 and is the smallest value in the array, and point B, which is xn plus 1, and it is the largest value in the array x. Along our route from A to B, we will visit some points. Of course, we will start from point A, and then we'll probably go to some gas station, refill there, and then go to another gas station, and then to another gas station, and then to another, and then at some point we'll get to the point B or point xn plus 1. So we see that we only need to store the positions in the array x. We don't need to consider any positions between the elements of array x. And so we will store in the variable current refill the position in the array x where we are currently standing. And we will initialize it with 0, because we start from point A, which is the same as x0 and has index 0 in the array x. And later, current refill will store the index in the array x where we are currently standing. We will also store the answer to our problem in the variable num_refills. At each point in the execution of the algorithm, it will contain the number of refills we have already made. And we initialize it with 0, because the problem statement asks us to count the minimum number of refills we need to do, not counting the initial refill at point A. So when we are standing at point A, we consider that we haven't made any refills yet. Then the main external while loop goes. And it goes on while we are still to the left from point B, because then we need to go right to reach our destination B. And we check this condition with this inequality that current refill is at most n. This means that the position or index in the array x is at most n, and so we're to the left from point B currently. In this case, we still need to go to the right. And first we save our current position in the array x in the variable last refill. This means that we made our last refill in the position current refill. And now we need to go to the right from there and either get to destination B or get to the rightmost reachable gas station and refill there. And the next internal while loop does exactly that. It gradually increases our current refill position in the array x until it reaches the rightmost point in the array x, which is reachable from the last refill position. So first we check that current refill position is at most n, because if it is n plus 1 already, it means that we reached our destination B, and there is no point increasing it further. If it's still to the left from B, then we look at the next position to the right, x current refill plus 1. We need to check whether it is reachable from last refill position or not. And first we compute the distance from the last refill position to the current refill plus 1 position by subtracting the values of the array x. And if this distance is at most L, then it means that we can travel this distance with full tank without any refills. And of course, at the last refill position, we could fill our tank up to the full capacity, and then we'll be able to travel for L kilometers. So this inequality checks if actually position current refill plus 1 is reachable from the last refill position. If it is, we increase the value of current refill and go on with our internal while loop. When we exit this internal while loop, we're already maybe in the point B, or we may be in some point which is the farthest reachable gas station. Now we compare it with our last refill position, and if it turns out that it is the same, it means that we couldn't go to the right. We don't have enough fuel even to get to the next gas station. and then we cannot return the minimum number of refills that we need to do on the way from A to B, because it is impossible to get from A to B at all, and so we return this result, impossible. Otherwise, we moved at least a bit to the right, and then we need to see if we are already in the point B, we don't need to do anything else. Otherwise, we need to refill there. So we check that we're to the left from point B with this inequality, and if it's true, then we're at some gas station and we need to refill. So we increase the num refills variable by 1. And then we return to the start of our external while loop. And there we again check if we're to the left from point B, we need another iteration. And if current refill is already n+1, then we've reached point B and we need to exit the external while loop. And in that case, we just return the answer, which is number of refills we've made so far. We've implemented the greedy algorithm from the previous lecture. Now let's analyze its running time. From the first look, it can seem that it works in n² time because we have the external while loop, which can make n iterations, and internal loop, which can make n iterations. So n by n is n², but actually we will show that it only makes O of n actions for the whole algorithm. To prove that, let's first look at the current refill variable. We see that it only changes one by one here, and it starts from 0. And what is the largest value that it can attain? Well, of course, the largest value is n+1, because this is the largest index in the array X, and current refill is index in the array X. So variable current refill starts from 0, changes one by one, and the largest value it can have is n+1. It means that it is increased at most n+1 times, which is big O of n. But that's not all we do. Also, we increase variable num refills here. But we also increase it always one by one. It also starts from 0. And what is the largest number that this variable can attain? Well, of course, it is n, because we only have n gas stations. There is no point to refill twice at the same gas station, so we can refill at most n times. So variable num refills goes to from 0 to n and changes one by one. So it is only changed at most n times. And so it is also linear in terms of n. And so we have at most n+1 iterations of the external while loop. Everything but the internal while loop takes their constant time. This assignment, this if, and this if with assignment. And the external loop and internal loop combined also spend at most linear time of iterations, because they change variable current refill, and it changes at most linear number of times. So all in all, our algorithm works in big O of n time. Let's go through this proof once again. The lemma says that the running time of the whole algorithm is big O of n, and we prove this by first noticing that the current refill variable changes only from 0 to at most n+1, and it changes always one by one, that the num refills variable changes from 0 to at most n, and it also changes one by one, so both these variables are changed big O of n times, and everything else that happens is constant time each iteration of the external loop, and there are at most n+1 iterations of the external loop. Thus, our algorithm works in linear time. In the next video, we will review what we've learned about greedy algorithms in general.